So this next problem here, number 7, I'm going to do the same thing. I'm going to get a least common denominator. The first thing that I am going to recognize is that x squared minus 9 can be factored into x plus 3 times x minus 3. So when it comes to what is the least common denominator, it needs the quantity x plus 3 and it needs the quantity x minus 3, and that's it. Everything is covered if that's the least common denominator. So I'm going to get each fraction to have a denominator of x plus 3 times x minus 3. And then I'm going to decide what do I need to multiply each fraction by in order to obtain that denominator. So in the first fraction, 6 over x minus 3, I'm missing the quantity x plus 3. What am I missing from the denominator is the x plus 3. So when I distribute the 6, I get 6x plus 18. In the middle term, I'm not missing anything, so it stays 8x squared. And then in the the last fraction, I'm missing the quantity x minus 3. So I'm going to multiply by x minus 3. So when I distribute the 4x, I get 4x squared minus 12x. And so here's what I'm going to do. Mathematically, what I'm doing is multiplying both sides by the quantity x plus 3 times the quantity x minus 3. But all that's going to do is cancel out the denominators. So I'm left with 6x plus 18 equals 8x squared. And let's be careful with this subtraction. I can do one of two things. I can change it to addition and I can distribute it to both terms, or I can just subtract the quantity 4x squared minus 12x. I just want to be careful that I end up subtracting both terms, which is a minus 4x squared, but this becomes plus 12x. So 8x squared 6x plus 18. So let's see what I'm going to do here. I'm going to combine 8x squared minus 4x squared and get 4x squared. I am going to subtract 6x over. So 12 minus 6 is 6, and I'm going to subtract 18 over. So plus 6x minus 18 equals 0. So this is what I'm solving. So I can, because it's an equation, decide that I want to divide both sides by 2. So 0 equals 2x squared plus 3x minus 9. So I am going to do the AC method, or you could do quadratic formula, or you could just guess and check. A times C is negative 18. 2 times negative 9 is negative 18. So the two numbers that multiply to be negative 18 and add up to be positive 3. Let's think. It's some combination of 6 and 3. So let's see what I want. In order to add up to be positive 3, I want a positive 6 and a negative 3. So I'm going to split up the middle term into 6x minus 3x. So 2x squared plus 6x minus 3x minus 9 equals 0. So then I'm going to factor by grouping. This says when I factor out a 2x, I'm left with x plus 3. And then here, when I factor out a negative 3, I'm left with x. And when I'm dividing out the negative, it does end up being plus 3. So then this still equals 0. So then I get 2x minus 3 times x plus 3 equals 0. So when does 2x minus 3 equal 0? Well, I add 3 to both sides. So here, I'll do it over here. 2x minus 3 equals 0. I'll add 3 to both sides. 2x equals 3. X equals 3 halves is one answer. And then when does x plus 3 equal 0? Is when x equals negative 3. Now, before I circle this answer, this is something that we have not had to consider thus far. So my final answers are 3 halves and negative 3. So I'm just going to jot that down here. 3 halves and negative 3. So something important that you should know about fractions is that the denominator of a fraction cannot equal 0. So it's possible that I have an extra solution if either of my solutions make any of the denominators 0. So when I look at what's written in black, those original denominators, if either of my answers make any of them equal to 0, they can't be included in the final answer. So the fact that -3 would make this denominator 0, and actually this denominator as well, the only answer is 3/2. So when you type in both answers, it's going to tell you that you're wrong, and you're going to wonder why, and it's because the denominator cannot equal 0. So you cannot let the denominator equal 0. I need to cross out the opportunity to equal -3. The only answer is 3/2.